Regents Review 2, projectile motion, circular motion, and gravitation. Here we go. All right, so we got quite a bit of review here on this. Good stuff. The components of a 15 meter per second velocity at an angle of 60 degrees above the horizontal are, all right, so angle 60 degrees. Looks like we can just calculate one of the components and be done with this question. So you always want to be looking out for those kind of things there. So, and then you got to watch out what they're giving you the angle relative to. So above the horizontal. So let's go ahead and find the x component. So 15 times the cos of 60. All right. Again, this is just a multiple choice question, so I don't need to show all the units. I do encourage you to use your scrap paper. Oops, let's get an actual number. 7.5 is the horizontal component, so that must be the right answer. All right. You don't even need to do the other one. It'd be 15 times the sine of 60, which, you know, I guess I could have, cos of 60 would have been 1/2, so I probably could have gotten that. All right, anyway, 2 kilogram mass is located 3 meters above the surface of the Earth. What is the magnitude of Earth's gravitational field strength at this location? So this could have been under gravitation, could have been under force, whatever. It's just Fg equals mg. When we're close to the Earth, g is always 9.8 newtons per kilogram, which is equivalent to meters per second squared, but they're asking about gravitational field strength. So we talked about that, right? I like the units of newtons per kilogram for g. I think on your reference table, they call it just acceleration due to gravity, 9.81 meters per second. But that's, you know, when we do Fg equals mg, we treat g as gravitational field strength, which if you go look at the equation here, Fg equals g equals Fg over m, and g is acceleration due to gravity or gravitational field strength. So they're the same number. Number 11, Hubble telescope's orbit is 5.6 times 10 to the 15th meters above Earth's surface. The telescope has a mass of 1.1 times 10 to the 4th kilograms. Earth exerts a gravitational force of 9.1 times 10 to the 4th newtons on the telescope. The magnitude of Earth's gravitational field strength at this location is, all right, this, you know, it seems like maybe we're going to be using big G, M1, M2, you know, remember that? So this unit is projectile motion, all right, so that's shooting stuff at an angle. Circular motion, that's Fc equals mv squared over r. Gravitation, that's Fg equals g m1 m2 over r squared. But also, Fg still always just equals mg. So for this problem, that's the radius above the Earth's surface. So that's not actually the radius. The radius would be the radius of the Earth plus that. Would get complicated. All we know, we don't even need to do that though. G is Fg over m. So it says Earth exerts a gravitational force of 9.1 times 10 to the 4th newtons. And the mass of it is 1.1 times 10 to the 4th kilograms. So look at newtons per kilogram. All it is 9.1 divided by 1.1. And I don't even have to put in the coefficients because those are just going to cancel, right? So it's 8.27 newtons per kilogram. It's 3. Turns out it's not that far away from the Earth, so the gravitational field strength doesn't go down by that much. 1 times 10 to the 3rd kilograms travels at a constant speed at 20 meters per second around a horizontal circular track. The diameter of the track is that many meters. All right, I'm going to draw a picture here. So the diameter, d is 1.0 times 10 to the 2 meters, which is 100 meters. That means the radius is 50 meters. And centripetal acceleration is AC, which is right here. Right here, v squared over r. So it's whatever the speed is squared divided by the radius of the track. It's going at 20 meters per second squared. Now, I guarantee one of the wrong answers is if 100 is on the bottom. Let's go ahead and do this. So 20 meters per second squared divided by 50, because that's the radius, is 8. If we had divided this by 100, we would have gotten 4, and that would be the wrong answer. So got to be careful. Easy equation, but they make it difficult by giving you the diameter, not the radius. That's the way they roll. New York State on the Regents. The physics Regents is not to be taken lightly. Fire drill. Okay, pause this.